Hello friends, how are you all? कैसे हैं बच्चा पार्टी? This is Dr. Sunil Kanal, your friend, philosopher, mentor and guide, taking your 10th standard revision lectures along with Atal Seva Kendra and Anubhavi Foundation. As you know, I have been taking your class. I am Dr. Sunil Kanal and this is myself. Now let's start with the new chapter today. That is the fifth chapter of Science 1, the revision series. First of all, let me first thank you all for the good response and the great response you are giving. This shows that you are studying for the exams very seriously and hope to see you with very nice and bright marks in your board examination. So let's come back here, dear friends, towards green energy. A nice chapter for 4 marks, and with options, it is for 6 marks. Okay. So when we are coming to this chapter, let's talk about towards green energy, and we'll understand this better by understanding what is energy. We have been seeing that we are using energy now. Actually, energy, from the point of view of physics, it is said that the capacity to do work, but we require energy, light energy, electrical energy, sound energy. There are so many types of energy, that is mechanical energy and so on. In our modern civilization, energy has become a primary need along with food, cloth and shelter. Okay, we need energy for diverse type of works. We require energy in the form of mechanical, chemical, sound, light, so on so forth. Okay, and we know, according to law of conservation of energy, energy can be converted from one form to another. Different sources of energy are used in for different forms of work, and energy for that we can use. In previous standards, we have studied about energy, sources of them, and the concept related to them. But now we are going to understand that how various sources we can use them for the generation of electricity or electrical energy, the methods that are used for that, and the scientific principles used beyond those things, and advantages and disadvantages of the various energy sources for electricity. Okay, the most important thing which we should know, that whenever we have to generate energy, it is with the help of a generator. So any proper energy source will run a turbine. Okay, you can understand, suppose this is a steam turbine. Okay, so in the steam turbine, steam is used to move that turbine. A turbine is a wheel like thing. What principle we are using? We are using the energy source for rotating or moving that turbine. This turbine in turn will be used for electromagnetic induction, that is magnetic effect which will help in production of energy in the generator. Okay, mechanical energy into electrical energy, that is the main principle which we are following for all the things in this chapter. Remember this, the principle remains the same throughout, whether you, whatever is the type of energy, electrical energy production source or type of electricity produced, whether it is hydroelectric, steam energy, thermal power station, the concept still remains the same. That is, the power energy source or a proper energy source from will be used to rotate or move the turbines. Turbines in turn will move the generators, and that will use to produce electrical energy. Okay, so most of the electric power plants are based on the principle of electromagnetic induction. That is what I was saying about, which was invented by Sir Michael Faraday. According to the principle, whenever magnetic field around a conductor changes, a potential difference is generated across the conductor. The the field around a conductor can be changed in two ways. If a conductor is stationary and the magnet is rotating, the field around the conductor changes. If a magnet is stationary but the conductor is moving, in either of the condition, if you keep magnet stationary and the conductor moving, or if the conductor is stationary and the magnet is moving, a electrical electricity is generated or a potential difference is created across the conductor, and this is what is the principle of working of any generator. Electrical power generating machine based on the principle is called as electric generator. Okay, this is how the electric generator works. Now let's talk of the thermal power generation. In a thermal power plant, again the same thing. The fuel use, when I say thermal power generation plant, means we are using heat energy to convert it into electricity. So the concept still remains the same. If you see the diagram or the figure in the textbook, the chart here remains the most basic thing which you have to explain, and you can explain the full figure along with it. The coal, that is, which is a primary fuel and thermal power station, example Chandrapur thermal power station in Maharashtra. Okay, it has a boiler in which the coal is burnt or the combustion of coal occurs, which will convert the water to steam because of the heat generated by coal. Now, this steam is used up to rotate or move the steam turbine, which in turn will move the generator and electricity is generated. Okay, then this steam is again sent back, means it is cooled and it is again sent to the boiler where it is sent as it is condensed and it goes and cooled back to water, which is again used in the boiler, and this concept continues. Okay, so in this way, the turbine is rotated along steam. Water is heated in a boiler using the thermal energy released due to burning of coal. Steam of very high temperature and pressure is generated. The energy in the steam drives the turbine. Thus, the generator connected to the turbine rotates and electrical energy is produced. So, chemical energy in coal is converted to thermal energy, that is heat energy. Heat energy is used up to heat the water, which gets converted into kinetic energy in the steam. Kinetic energy then is used to rotate the turbine to the generator, and then generator will produce the electrical energy. This is the concept behind the working of thermal power station. So Bacha Party, concept still remains the same. We are using same method in all the, whenever you will see the next topic, you will understand that this thing is happening again and again. Remember this flow chart and you can answer your question. Don't have to remember all these points here. If you remember this, you can write in your own words, and that also authentically getting full marks for your paper or for your answer. Okay. Now, problem associated with thermal power plant. What is the problem? Air pollution due to burning of coal is a major problem. Okay, it helps in emission of carbon dioxide, sulfur dioxide, nitrogen oxide, which are harmful for the health and they are harmful for the environment. They cause greenhouse effect also. This may cause serious health problems related to respiratory system. Then we know that the reserves of all the fossil fuels, including coal, is limited. Therefore, in future, it may cause limitation to the availability of coal. So these are the disadvantages associated with thermal power plant. Now coming to the nuclear power plant. Okay, example is Tarapur atomic power station. Okay, we have many other Kalapakkam, etc. You must be knowing them. So in that also, what is the main concept? Here we are using the nuclear energy or the atomic energy. So nuclear reactor for nuclear fissions. Okay, so in that, because of the nuclear fission, where the fuel is uranium or plutonium, which are radioactive substances, system, now because of the fission, lot of energy is released, which will again be used up to heat the water where steam is produced. It will also work on the steam turbines, again on the generators, and electrical energy is produced. And it is has a system of conversion of, again there is a rotation, that is steam is again converted to water by condensation, by cooling, and it is again used in the boiler where the energy from the nuclear fission is again used for converting it into steam. Okay, thus this works in the same way. So nuclear energy converts to thermal energy into the kinetic energy in the steam. Kinetic energy is used to rotate the turbines, and turbines will be used to rotate the generators, and thus electrical energy is produced. Okay, so this is what is the concept of production of nuclear energy, means nuclear power in the nuclear power stations for conversion of nuclear energy into the electrical energy. Okay, so when neutron, so how the nuclear fission occurs? When neutron is bombarded on atom of uranium 235, it absorbs the neutron and converts into isotope uranium 236, which is extremely unstable, converts into barium and krypton through a process of fission, and releases 200 mega electron volt energy, which is a very high amount of energy. Okay, this concept is used for conversion of that heat energy generated in the atomic reactors, will be used to convert the water into steam, and thus the process of electricity generation continues. Okay, so you can see how the bombardment of the uranium atom occurs, and it converts into barium, krypton, and three more neutrons, which will again attack the three new uranium atoms, and the nuclear fission is a chain reaction. Of course, there are nuclear neutron absorbers, okay, that is palladium and lead rods and lead chambers, where they will be absorbed back, and so that it does not cause any untoward reactions or a blast in the reactors. Okay, so they have a controlled chain reactions. So now the next is natural gas power plant. Okay, so again the gas turbine electric power generation, compressed or pressurized air or the gas. Okay, and the source is natural gas. In the combustion chamber, they will react to form the heat which will be used in the gas turbines. This heat will rotate the turbines, not the steam here, and the generators, and again the electricity is produced. So chemical energy in the natural gas is used for converting into kinetic energy generated along with combustion of natural gas into rotating the turbines, and then electricity is produced. This is how the natural gas power plant will be working. Okay, in this plant, the turbine is run by a gas at a very high temperature and pressure generated by combustion of natural gas. A flow chart showing various stages of power generation plant based on natural gas has been shown to you in the last slide. We just saw how the things will happen and how the electricity is generated in the natural gas power plant. Thus, it is again, it's a very advantageous method because it has less pollution, but again the resources of natural gas in our world, in our this earth, is limited, and again it can be a very disadvantageous thing in the future. Now coming to the next, that is hydroelectric power station. Okay, you must have heard about Koyna Dam and the various dams. Okay, Bhakra Nangal Dam, etc. So they are generally huge dams which are constructed along across the rivers to obstruct its water, and then that water which is released from the dams can be used for converting the kinetic energy of the water into electrical energy in hydroelectric power plants. Hydro means from water. So kinetic energy in flowing water or the potential energy water reservoir is a conventional source of energy. In hydroelectric power plant, this potential energy in water stored in the dams converts into kinetic energy of water flowing from the dams, and it will rotate the turbines which are at the base of the dams. Okay, at the basal parts, and the rotation of the turbines will in turn rotate the generators, and electricity is generated. So potential energy water which is stored in the reservoirs to kinetic energy in the flowing water. This kinetic energy will move the turbines, and turbines will in turn move the generators to produce electrical energy. Now water, now this is an important question. Many a times the board people do ask this question. The board's favorite question, I can say. What are the advantages and problems associated with hydroelectric power generation plants? The here plant means the site where the hydroelectric power is being generated. So since no fuel is burnt in hydroelectric power generation, there is no pollution resulting from combustion of fuels. If there is sufficient water, it is possible to generate electricity as and when necessary. Although water reservoir is used for power generation, it can be also replenished during rainy season, okay, leading to uninterrupted power generation also. Now, what are the main problems or the disadvantages? The backwater, due to storage of water in dam, may submerge the villages or towns in that area. This leads to problems of rehabilitation. Even for construction of dam, we have to relocate many people, and this is again a problematic thing. Okay. Moreover, this can also submerge forest as well as fertile land. The obstruction to the flow of water may have adverse effects on the living world in the river. Besides, construction of dam can make the earth's crust weaker, may be prone for earthquakes also. So again, that is a disadvantage of a hydroelectric power plant. The next is wind energy power plant. More useful, a more better way, a green energy, I can say. The kinetic energy in the wind has been used since long for lifting of water for driving. Okay, that is floor mills, etc. The wind energy can be also used for electric generation. The machine which converts the kinetic energy of wind to electrical energy is called wind turbine. Sorry. This diagram is essential for you all. You should know this diagram also for 2 marks. Sketch and label the windmill. As the wind strikes the blades of the turbine, the blades rotate and the axle of the turbine is connected to electrical generator through a gearbox. The function of the gearbox is to increase the rotations per unit time. Thus, the rotating blades drive the turbine, and the turbine in turn generates electrical energy or electricity. So, kinetic energy in the wind into kinetic energy in the turbines used to convert that into the motion or rotation of the generator, and electrical energy can be produced by that method. The next is the most important green energy is a solar photovoltaic cell. Solar photovoltaic cell converts the solar radiation energy directly into electrical energy. This is called a solar photovoltaic effect. The electrical energy generated through this method, okay, is used as a DC current or the direct current. These solar cells are made up of special types of material called as semiconductors. Example, silicon. A silicon cell, solar cell of diameter 1 centimeter, dimension 1 centimeter square, can produce electricity of around 30 milliampere and potential difference of 0.5 volt. Thus, if I increase the dimension to 100 centimeter square, I can produce the electricity of 3 ampere, okay, and a current voltage of 0.5 volt. Remember, the potential difference available of solar cell is independent of its area, so potential difference does not change, the current changes according to dimensions. Okay, the power available from the solar cell is DC, so it is applicable when where we need DC power. Example, electric lights based on light emitting diodes, that is LEDs. The energy can be directly used. However, since the energy from solar cell is available only in presence of sunlight, the energy has to be stored in batteries for use later on. That's a disadvantage. However, most of the equipment in domestic as well as industrial use run on AC power plants, and therefore you require an inverter to convert the DC current into the AC current. Okay. We have seen that many solar panels can be constructed, okay, to generate a better amount of energy or electricity. Okay, so of course, but it is a very costly affair, and if the cost part comes down or the component comes down, then they can be the future of our country. Okay, so solar cell to a battery will convert, battery will use that DC current, will send it to inverter, which will convert it into AC current and can be used for the electrical components and instruments. Now, solar thermal power plant. We have seen that thermal energy generated from coal and nuclear fuel can be used to generate electricity. Similarly, thermal energy can also be generated from solar radiation and can be used for electricity production because sun is a free source of heat energy for us. Okay. So in this way, dear students, we have completed the very important topic in a very short summary. Now let's see certain questions regarding the same. How can we get the required amount of energy by connecting solar panels? Okay. So again, an important question. You can just see for 2 marks, you will write these points and you get the full 2 marks for it. In solar panels, many solar cells are connected in series and parallel combination to generate the required current and potential difference. So they have to be connected either in series or parallel combination. In series combination of solar cells, the potential difference is the addition of the potential difference of individual solar cells while the current remains the same. In parallel combination of solar cells, the current is the addition of the current of individual solar cells while the potential difference is equal to the potential difference from an individual cell, so it remains the same. Many such solar panels are connected in series to form a solar string, and many such solar strings can further be connected in parallel to have a solar array. So, solar panels, solar cells, solar panels, that is array, string, etc., can be created. Thus, by connecting many solar panels in series and parallel, the required amount of energy can be generated. So, this is how you are supposed to write this answer. Let's see the next question. Other than thermal power plant, which power plants are use thermal energy for power generation? Okay. In what different ways is the thermal energy obtained? So apart from thermal plants, power plants based on nuclear energy and solar thermal power plants also use thermal energy. What are the ways? In thermal power plants, coal is burned to obtain the thermal energy. In nuclear energy power plants, we have the fission of nuclei of atoms like uranium or plutonium to generate thermal energy, and in solar thermal power plants the thermal energy is obtained from the solar radiations. Okay, in this way, dear students, we can answer the questions very easily from this chapter. So dear students, we complete this chapter. I hope you have understood. You will do it nicely. God bless you all. Thank you very much, and keep studying and always be bright stars in your life. Okay. Thank you. God bless you.